Okay, my name is Ray Leftwich. I'm the city engineer for the city of Lincoln. I've been with the city now for over 11 years. In the 50s and 60s, the city of Lincoln operated its own municipal landfill, and it operated in that capacity up until the late 60s, and then it was transitioned to just being yard waste, and it continued in that capacity until the mid 70s, at which time it was closed. Fast forward into the 90s, then the regional boards, the state water boards, started looking into a lot of these landfills and potential issues coming from them, and in 2003 issued an order to begin the process of decommissioning the landfill, and ultimately in 2014 issued the cleanup and abatement order, of which we have just recently implemented for the closure and cleanup of the landfill.
They would come out and excavate a trench, put the waste materials, just typical household waste in, and then light it on fire, and then backfill it with soil. And there's approximately 5 to 6 trenches out here that were operated that way. 70s and 80s, they were looking at all these old burn dumps and finding out that groundwater was moving into them and out of them and carrying contaminants off-site. And that was found in monitoring wells. Since then, the California Water Quality Control Board has asked for sites like this to be cleaned up, and sometimes that means clean closure. We'll excavate all the waste material out and haul it off to a licensed landfill site. Sometimes it has to go to a hazardous waste site, and sometimes just to a regular Class 3 municipal solid waste site, such as where we're hauling ours to, which is Ostrom Road landfill in Wheatland, which is about maybe 15 miles from here. So what we ended up doing was, after doing a characterization of the site, we designed a dewatering system. And the dewatering system, rather than using conventional wells to pump the groundwater out, we used a trench system. And what the water board had mandated was that the water table had to be lowered to a minimum of at least 5 feet below the bottommost elevation of the waste. So we designed a trench system around the perimeter of the site, and the site encompasses about 6 acres, and it's a relatively flat site in pretty much a square shape. And then that water within the landfill would move into our trenches, which are filled with gravel, and then the flow of that material, or that effluent, would then move to the sump locations, which are constructed at the corners of the trenches, and then it's then pumped out and into the sanitary sewer.
Ultimately, that's what we implemented, and construction costs on that, as opposed to being $14-15 million, we ended up just about $2.1 million, so substantial savings to the city.
The trench that we're putting in runs around the perimeter like this, and then is pumped out into a pressure pipe system that then discharges into the sanitary sewer. Now, if you look at this drawing over here, you'll see a cross-section through showing where the waste materials are at, and these are 2 different cross-sections showing basically the same thing. The regional water table being up here, up in the waste, the 5-foot separation depth here minimum that they have to achieve, and then this is the trench on the side, one side, this is a trench on the other side, and this is the configuration of where the water table would be drawn down to in order to achieve that minimum 5 foot. And actually we've designed it so we'll have a factor of safety so that we'll have like a 10-foot separation. If you go over to this drawing here, this shows again the trenches in the center of the landfill, and the perimeter dewatering trench, as well as the corners showing where the sumps are at, and then a piping system that will take from those sumps and discharge all the water into a manifold, which goes to this outer piping system that'll take it to the sanitary sewer.
Initially, there was a certain level of unknown at how much water we would be pumping off site. Would we be overloading the wastewater treatment plant? Ultimately, and even during this past year, which was fairly wet, the peak amount of discharge was to the equivalent of like 20 single-family homes, and it seems to have settled somewhere around 16 or 17 of what we call an equivalent dwelling unit. So fairly moderate amount, certainly nothing that's going to overload our treatment plant facility.
We have at some locations as deep as 45 feet that we have to excavate a 3-foot wide trench. In other areas it can be as shallow as 20 to 25 feet. And the material here is then removed and then replaced with a crushed rock, and then the bottom is graded to drain to each of these corners and then pumped out. We have had some challenges with, because they're deep trenches, of some caving issues. So we've had to come up with some solutions during the construction process to mitigate that.
The upper levels of the trenches were unstable, and if we could get down to take it down 10 feet on the top, the bottom 30 feet would hold no problem. We were having issues with the top falling in. So we just actually found a way to make a wider bench, lower the top sections down to take away all the pressure off the top edges. And once we did that, the walls stood open and we were able to go along and finish the project. Just had to take the pressure off the top of the trenches.
I think some of the lessons learned out of this project, and again, we had some of the initial work dates back into the 90s, and with a lot of the same consultants working on it, and there was a little bit of a tunnel vision of a particular method of remediation. But as the city started looking at the costs and reached out and got second opinions, sometimes it's worth a little of expense. Reach out to a third party and go, what do you think? Do you got another idea? Maybe they do, maybe they don't. In this case, with Holdrege Kull, we were able to implement what we found was a much more cost-effective method, and the water board is very happy with it, and it's been very successfully implemented at substantial savings to the city. Reasons this project was a success was teamwork amongst all parties involved. So the city, Holdrege Kull, and its contractor ICS, all working collaboratively to have a productive project. Challenges arise, which they're always going to in any construction job. These challenges are communicated and solutions were found, and the project continued to move forward without additional delays and any excessive additional expense.
So we had done some calculations using the hydraulic conductivity, being very conservative with it, with the lowest hydraulic conductivity and some infiltration rates that we anticipated, and we thought it would take 2 to 3 years to dewater the site to the compliance elevation. But in fact, early on we saw a response in our monitoring wells that were immediately adjacent to the trench, our dewatering trench, and shortly thereafter we started seeing a response in monitoring wells that were interior to the site, so we knew that our project was having an impact all the way across the entire site, from the center all the way outward. So it took 9 months to be in compliance with the 5 feet of separation from the bottom of the waste and the top of the groundwater. The regional board was very pleased with the outcome of the project. They turned around and issued a letter of substantial compliance shortly after we showed that we were impacting water levels across the site, even before we had achieved full compliance.